Hello everyone. Today I would like to take a session on operating system which is covered in BTech 4th semester under the regulation of 20. Myself, I am Madhavi Devi. I am working as assistant professor in Institute of Aeronautical Engineering College. So today in my presentation, I would like to discuss these are the contents in my presentation. So the first one is operating system objectives and functions, the computer system architecture, operating system structure, operating system operations, and evaluation of different operating system and system calls. So after this completion of this presentation, the students are going to get these are the outcomes. So they able to describe the general organization of the computer system, and they able to describe the components in modern and multiprocessor computer system and discuss the different evaluations of operating systems are used in various computing environments. So let us go to the content. The first, initially the computer system structure. How actually the computer structure is designed. So there are 4 components in a computer. So if you observe that the parts of the computer, initially hardware and operating system and application programs and users. So let us discuss one by one the component. So hardware. So all have you seen the computer, and you may observe the different parts of the computers. So those are the hardwares of the computer: CPU, memory, I/O devices, printer, and different parts of the computer. What you have seen in a system. These are hardware. And now to make these parts functionality, user able to interact with this. So we require some software. That software is operating system. So what operating system will do is, it will control and coordinate the use of hardware among various applications and users. So this software, it will control and coordinates the different parts of the computer. So here, this operating system consists of, there are 2 kinds of the applications: system applications and user applications. So the system applications is meant for the programs what you have defined. This makes the different parts of the computer is going to function. And application programs are some of the user applications like databases. So some of the daily day-to-day life applications. So different kinds. These where user can use the computer for their daily routines life. So those are commended to the application programs. So these the system programs are word processors, compilers, web browsers, databases, video games. All these are system application programs. So now with this computer system structure, the one of the part is users. Without users, there is no system at all, because users are nothing but the people who are using the system. The people are machines and other computers. These are categorized as a users for this in the computer system structure. So now come to the definition of operating system. What this operating system is doing. So it is a tiny program that acts as an intermediate between a user of a computer and computer hardware. So what it means? Operating system is nothing but a program. It acts as an intermediate. Suppose this is a person, this is a user, this is computer, hardware of computer. So now this operating system is act as an intermediate between user and hardware of the computer. In other words, it acts like a translator also. It acts because this is a programmer which you can allow to use the system. So this is nothing but operating system. So what this operating system major goals? So it will allow to execute user programs and make solving the user problems easier and make the computer system convenient to use and make the computer hardware in an efficient manner. These are the major goals, because for any program we are writing, we have to define the goals. So that goals are, it execute user programs convenient to use and making user problems are easier, and computer hardware have to use in efficient manner. So here now, how actually there is no fixed definition for the operating system, but here everything, because once we are purchasing some computer, then vendor ships an operating system along with the computer. Without operating system, there is no use of computer because it's not going to functional. So the one program running at all times in the computer is the kernel, and where this kernel is a part of the operating system. It's also a program. It is inside the operating system, and it makes your operating system also start running. So it has to run all the times on the computer. Everything else, the rest of kernel is also a system program only, which makes the operating system also start running. So other than that, there are system programs what we have discussed in the structure: system program and an application program. System programs, it ships along with an operating system. Ships in the sense of here, it comes along with, include along with operating system, but not part of the kernel. And application programs, all programs not associated with the operating system. Suppose if you take it up, compilers, different languages and databases, these are all is going to be application program. And today we are using the OS, not only this operating system, not only for general purpose, and we are using these operating systems for mobile computing and also including different middleware technologies. The middleware is in the sense of that a set of software frameworks that provide an additional services to application developers such as databases, multimedia and graphics. So here, so sometimes for mobile computing, we require different middleware. The middleware is nothing but a frameworks which provide additional services along to the application developers along with operating system. Right? So this is abstract view of the computer. These are the what we have discussed in the previous. So the same here, the computer hardware and operating system and system and application programs. If you observe here, compiler, assembler, text editor, database system and etc. These are different system and application programs, and these are different users are using the system. Right? This is abstract view of the computer. If you observe the computer, so hardware, proper machine, and inside operating system has to come along with the system, and then inside that operating system we have two kinds of programs: system and application programs, and different users are communicating with the operating system to make use the computer in efficient manner. So now we learned till now? What is operating system? What are the different components of a computer's abstract view of the different components involved in a computer. Now let us go to the what this operating system little in detail. What operating system will do? There are two kinds of the views. There are two kinds of views. One is user's point of view. User point of view. And another is system point of view. So let us look at user perspective. Users are means that whoever we are using the computers. So what we are assumptions, what we will do, we always want convenience, ease of use, but we are never care about of the resource utilization. How the resource, because the computer itself has to work with help of operating system, and there we never bother about of the how the resources are utilized. Here the resources are nothing but the CPU, I by O in the sense of that keyboard, input, output is monitor or printer or different devices, I by O devices such as keyboard, monitor, etc. Memory. These are different kinds of resources are there in our system. So as user perspective, we never bother about of how we are utilizing the resources, but we always want ease of use. Ease of use means that suppose if you take anything, how if now we are looking of the touch screens and we want speed. Suppose if I type some application and whether the performance it is coming out, the results is very immediately or not. So very good performance. We will look only the good performance and ease of use. Now come to the shared computer. If you take the shared computer, what is meant by shared computer means that a computer is going to use by many users. That is shared, because whatever applications are built inside the computer can be used by different people. So such as in early days, before even single computers or desktop computers evolved, there the mainframes are mini computers, because mainframes are going to use, these workstations are going to use for a big applications for computations. So mini computers must keep all users has to be happy. See, suppose if I am, I have one system and 10 users are coming to use such a system. So what as a person I have to make as an operating system, I want to give convenience and ease of use, as well as I have to satisfy, I have to make all the users be happy to they have used the system efficiently. So this is all. So here now for this, what actually operating system is going to do, that it acts like a manager. So the first is in that managing roles, it will identify how efficiently the resources can be used. Resource allocator. The first functionality of the operating system is it is a resource allocator and control program and control the program, making efficient use of hardware and managing execution of user programs. And here users of the dedicated systems such as workstations have dedicated resources but frequently use the shared resources from the servers. Some computers have little or no user interface, such as embedded computers. If you observe here, embedded computers in devices and automobiles. So what do you mean by embedded computers? Means that here if you take it off some ICUs and some devices, it itself is having of some for processing, for calculating. The computers are inbuilt inside the devices for the calculation and for the specific. That is embedded computers. Embedded means the computers are embedded into the inside the device and automobiles. So what is this embedded systems functionality run primarily without user intervention? Suppose if you observe in the railway signals places, so there actually signals will be happen automatically. So how it is happen automatically means that by inbuilting of embedded computers, by writing a program inside that, and we are building inbuilt that chip inside that traffic signal, so that actually it will do functionality. So that's about of this. Now come to the organization. So we learn structure, we learn what is operating system, we learned different components of the computer system and what the operating systems do actually. So major functionality of the operating system is a resource allocator and a control programmer. So now let us see computer system organization. So here, if you observe this figure, there are different resources are connected to the system bus, right? CPU, disk controller, USB controller, graphics adapter. These all the different devices are connecting to the system bus to get some information from memory. So the computer system, what are the operations we are going to perform in a computer? One or more CPUs, device controllers connect through a common bus, providing access to shared memory. So the another operation, concurrent execution of CPU and devices competing for memory cycles. So because all this concurrent execution is in the sense of that, so it the different CPUs has to execute parallelly. That is concurrent execution of the CPU and devices competing for the memory cycles. These are the different operations we are going to perform. So here, see, if you observe here, disks, mouse, keyboard, printer, monitor and all. The disk controller, it is also a program. IARE devices in the above figure. IARE devices and CPU can execute concurrently, and each device controller is in charge of a particular device type, and this device controller has a local buffer because each and every device is having a in charge. That in charge is nothing but a device controller, and this device controller is having a local buffer and also a device driver. Suppose if you may have noticed that, see, suppose you want to connect some external devices or external USB sticks or external input devices like keyboards, wireless devices, external cam card, external devices, you want to connect it. Sometimes it may ask that some will be like the driver programs automatically installed, and something it was expecting that you have to install the device drivers so that actually it can be configured automatically, and so that your device is going to be compatible to your computer and make functioning properly, right? So the device drivers means that it's also a program which will make you compatible to your computer to your external devices. So further, each device controller has an operating system device driver to manage the devices, and CPU moves the data from or to main memory or to or from local buffers. So these are the different operations we are going to perform in a computers, right? And IARE is from the device to local buffer of controller. And this device controller informs the CPU that it has finished its operation by causing an interrupt. So here, because obviously you are going to use the system for certain operations, and this device controller is a type, is in charge of particular devices, and inside the device controller is having of device drivers to manage the different devices. So the CPU moves the data from R2 the main memory, R2 or from local buffers, right? These are the different operations. Once the operation is finished, actually CPU triggers an interrupt. I have finished the task. So how actually the common functions of the interrupts? So not only completing a task, but in between, suppose some high priority task comes, then also it will generate an interrupt. What are the different common functionalities of the interrupt? Interrupt is nothing but, see, some function, some work is going on. Some person is coming and try to ask something, because then it's you are raising an interrupt, right? You are stopping your work and you are trying to answer to that person. That's nothing but an interrupt. So here the common functionalities of the interrupts means that the interrupt transfers. Once the interrupt occurs, then the CPU transfers the control to the interrupt service routine, ISP in general, because you may have studied all these terminology in your computer organization and architecture subject also. So here in this operating system, we briefly discussed, not in detail, briefly discuss how actually the computer systems operations are performed, right? So in part of that, when interrupt occurs, it transfers control to the interrupt service routine, generally through the interrupt vector, right? Which contain through the interrupt. What interrupt vector contains? It contains address of all the service routines. It contains address of the all service routines. So interrupt architecture, it itself is a separate mechanism inside your operating system. Interrupt architecture must save the address of interrupted instruction. Obviously, right? Suppose if one person is coming and you are doing the work, and you will save that work, then you will answer to other persons. So here also in the same fashion, it is also is performing the interrupt. This architecture itself will save the address of the interrupted instruction. Whoever is getting interrupted, that place, actually that address you are going to save. So once actually a trap or exception is a software generated interrupt caused either by an error or a user request. See, suppose while you are doing the work, how you are going to generate an interrupt? System will generate an interrupt, right? The another way is a trap or an exception. It is a software generated interrupt. You can also, the other user also can enable the interrupt. Suppose then the priority is high, then it will start triggering the interrupt. So here what is the mechanism is a trap or exception is a software generated interrupt caused either by an error or a user request. So here that's why we have that different kinds of interrupts are there in the operating system, that are hardware interrupts, software interrupts. So suppose a user wants to generate an interrupt, that is trap or exception, software interrupt. So trap or exception, it is a software generated interrupt. Even this is a very important bit. You may get it sometimes in your GATE applications also, GATE competitive examinations. So, which is actually a software generated interrupt caused by the users. So then you have to select a trap or exception. So let us we see, suppose if a CPU is generating his CPU, because obviously CPU is doing the processing. The user programs how actually the interrupt timeline when interrupt is occurring, how it is going to be functioning. CPU, if you observe here, CPU, what CPU will do? It is processing the user programs or user applications. So this happily the user program is executing. So now when actually at that time what is actually iBeaver device, actually iBeaver device are, because other devices are other parts of the computer only able to do interrupts to perform, or CPU while in the user program you want actually some inputs or some outputs, or you want to share some information inside the memory. Then actually if the application requires some data, that time also you have to trigger an interrupt and ask the particular device, please share the information. So that time actually interrupt has to be happen. So here if you observe now, we in this figure it is showing of the CPU and iBeaver device only. So initially the user program is start running, and here that time iBeaver device is idle, because still that point actually IO request is happen. So once the iBeaver request is happen, then actually it has to trigger an interrupt. That's why if you observe here, it has to wait till the iBeaver device has to give the information back to the user application, to the CPU, right? So that time, so up to this point actually this iBeaver device is idle, and it is a processing of iBeaver request, and it is giving a sending of the request information to the user. So when actually CPU is executing, this is a straight line. When actually CPU is idle or interrupt is occurred, then or wait for an event, then actually that time actually CPU even can trigger or move to some other application, save this status and move to the other application, or here it may be allowed to wait idle time. So once actually it is getting the information back, then it will start executing like this. So here also when iBeaver request till comes, actually it is happily going and giving try to executing. And when the request comes, because iBeaver request, when the transfer is completed, so if you observe that the transfer completed, then interrupt signal, interrupt handled, then again like this actually the process different applications are going to be happen. I hope so every student is understanding of this. So here interrupt handling, what are the different in before also we have discussed, when a CPU wants some information or any device wants some request for another device, some request, and it wants to collect some information and it has to give some information also, any communication has to be happen through with the help of interrupts only. This when interrupt is happen, what I am saying that, suppose if interrupt is happen, then whatever work you are doing, you have to save the state of this work. So whenever actually this interrupt, operating system is preserves the state of the CPU by storing registers and the program. How actually we have to save? Because CPU by state of the CPU by storing that inside the registers and program counter. Why I required? If you observe in the computer organization, you may know that some registers are there, AX, BX, inside that ALU itself and inside the CPU itself, these registers are there. So you don't save it off for this information into the memory. Actually, when the interrupt is raised, then this information will be stored in the registers. Registers are tiny storage elements which are available inside your CPU itself, right? Because what is the benefit actually? Why should I do register inside? It means that if it is available inside, you can able to get back and go back, return back very fastly. That is the main purpose. You can able to achieve the performance is higher. That is the main motto actually. But actually you can't able to store multiple storage. That's why actually you have that main memory and secondary storage, that all the divisions actually, the categories of that. So here the operating system, when actually interrupt occurs, the operating system's duty is it preserves the status of the CPU by storing inside the registers and the program counter. So, and it also determines which type of interrupt has occurred. So, there are two kinds of interrupts, polling and vectored interrupt systems. So, in polling, CPU steadily checks whether interrupting device directly checks whether the device needs attention or not. Right? So, it's like polling in the sense of that the CPU directly checks each and every device whether are you required my service, are you required my service. Like the polling, it will be happen. In the vectored interrupt system, it is a processor to the appropriate interrupt service routine with the some addresses inside the ISR. So separate segments of the code determine what action should be taken for each type of interrupt. So this is what interrupt handling, and here how actually interrupt driven IBO cycle. And here if you observe that CPU, and because each and every, I already informed that CPU and each and every device is having of their own controllers. That controller is in charge for the particular device. So the CPU, now we will check that CPU is executing. The device driver initiates the IBO, and when it initiates, it is going to the IBO control. It initiates IBO and IBO controller is taking part, and then if input is ready, whatever information it is asked by the CPU or by the device driver, if it is ready, output or complete or error, anything, whatever, then it will go back to the CPU. Receiving interrupt transfers control to the interrupt handler. So then interrupt handler processes the data and returns from the interrupt. Once that CPU resume processing of interrupted task. Once actually this process is over, then only it will resume, the CPU will resume the processing of the then once the processing is resumed, then it will go back to the again in the starting, and it will start executing the next instruction. This is what actually interrupt driven IBO cycle. Because CPU is, suppose if an application program doesn't require any input, any output, then it doesn't require any interrupts, right? If anything, it requires to interact with other devices. Then this is actually, this is the picture. This is the way actually it will be handled. After once IBO starts, the control returns to the user program only upon IBO completion. IBO in the sense of input output completion. It will wait. Instruction idles the CPU until the next interrupt. And it also wait loop contention for the memory access. Contention for the memory access means so many devices are trying to contend for the memory. A memory is also a resource, not only CPU, because different CPUs, one or more than the CPU, or different other parts may require access to the memory. That is actually wait loop. wait loop, then actually obviously you have to wait till your chance is going to get. So at most one IPO request is outstanding at a time and no simultaneous IPO processing. So this is what, after IPO starts, the control returns to user program without waiting for the IPO completion. So how actually the control will be written back? What are the mechanisms is there in the operating system? So once actually control returns to the user program, what are the things are there? Means that by invoking system call, requested to the OS to allow user to wait for IPO completion. And another thing is device status table. It contains, so this table contains the information of the status about of the devices, indicating its type, address and state. So the state is nothing but, if you next later chapters we are going to study of that, whether it is in a process, ready, running state, ideal state and all those stuff we are going to study in the process diagram. So, and voice indexes into IPO device table to determine device status and to modify table entry to include the interrupt. Now come to the next concept, storage structure. So this is also we have studied. This is also one kind of main memory is one kind of resource. The memory is used for the storage of the information that the CPU can access directly. So there are two kinds of the memories, RAM and ROM. Every person knows that RAM is nothing but random access memory and ROM is nothing but read-only memory. So random access memory, so whatever information you are stored, it is volatile, means that the information it will be lost very immediately after the power is going to be off. So that is nothing but volatile. Typically random access memory is in the form of dynamic random access memory. Nowadays actually we are using a dynamic random access memory. So that we will discuss it in all the what is SRAM, DRAM and all those stuff in the computer organization and architecture. Now we are not going in detail about of all those stuff. We just want to know that very brief about of what are the storage structures are available inside. The secondary storage. So the HD hard disks, extension of the main memory to give it up. I want more memory. So the hard disks, these are non-volatile. Obviously, if you observe that if you store it into inside your hard disk, once you power out, power off also, then your information will be sustained in your system. Means it never lost. You never lost your information. That's nothing but non-volatile. Thus, if you want to store it in non-volatile, that is you have to store it in a secondary storage. Hard disk drives. So now if you HDD, you may heard so many of the places HDDs and non-volatile memory NVM devices. These are the different. Now come to the, I just want to give it a brief gesture inside that. So here, what are the different storage definitions and notations we are going to use it. So here the storage element we are calling it as bit. A bit contain either 0 or 1. A byte is nothing but 8 bits. A byte is nothing but 8 bits. A word is made up of 1 or more bytes. A word is made up of 1 or more bytes. The computer storage, along with most computer throughput, is generally measured and manipulated in bytes and collection of bytes. Kilobyte, KB, 2 power 10, 1024 bytes, 2 power 10. Usually we will term it as 2 power 10. 1 kilobyte is 1024. Megabyte, 2 power 20. Gigabyte, 2 power 30. Terabyte, 2 power 40. Petabyte, 2 power 50. So sometimes actually the manufacturer vendors, they will use it up rather than the 1024,000. Like 1 megabyte is 1 million bytes and gigabyte is 1 billion bytes. It's based on the different country, different regions, the people will use it. That uh, so don't be confused over there. So kilobyte is 2 power 10, megabyte is 2 power 20, gigabyte is 2 power 30, terabyte is 2 power 40, and petabyte is 2 power 50. That you have to remember. So how actually storage hierarchy? What are the parameters actually it will be involved in that hierarchy? So we will look at the speed, cost, volatility. Right? So caching, while the storage system organized in this hierarchy. Caching, copying the information into faster storage device. Because you may observe that the browser information is stored in a cache memory. So suppose you want to frequently visit the sites, so that browsing information will be stored in cache memory. Because it is available inside the CPU itself. So the main memory, it is viewed as a cache for the secondary storage. And device drivers for each device controller to manage IBO and provides uniform interface between controller and kernel. So this is actually the diagram of storage device hierarchy. So if you observe here, the top layer registers, which are very small in a storage. Registers. I can't able to store 20 GB of information inside the register. I can't able to store it of even 1 MB information in my registers. Registers, it is used while in the manipulations, while in the calculations. Cache memory, it is little bit more than register. And main memory. These all three we will term it as primary memory. Primary memory. Right? So these all are once the power is off. Actually, volatile means that your information you are going to lost. But for processing perspective, these are very faster. And now come to the non-volatile memory. Hard disk drives, optical disks, magnetic disks. This non-volatile and these are the hard disk drives are secondary storage, and optical disks and magnetic tips are tertiary storage. But you have to load the information from the magnetic tapes to the computer. It is little slower. I hope so. Everybody may come across that experience. Right? If the information is available inside the computer, you may access very fastly. The same way, if you are installing a tape inside your disk drive, then the playing that movie or playing that or accessing the information from the disks are very slower. This is what actually storage. I hope so. Now under this storage, you have come across the terminology volatile, non-volatile, what is meant by primary storage, what is meant by secondary storage, what is meant by tertiary storage. So now come to the computer system architecture, very brief. So if you look at the architecture of the computers, in olden days or now we are using a single processors. Single processors are nothing but one processor is resided in a computer for your operations. Multiprocessors, more than one processor is inside your system under umbrella of one operating system. That is multiprocessors. This multiprocess we are going to call it as parallel systems also and tightly coupled system. These are the two technical terms we are going to. So what are the advantages with the multiprocessors? So because why should I require more than one CPU in my system? Means that to achieve my throughput, increased throughput means that I want to very fastly wants to submit back my application result. Throughput is nothing but the number of programs are going to run per unit of the time, right? That is nothing but I want to increase that. Suppose with single processor, if I were able to finish the 5 tasks in a minute, with multiprocessor I can able to finish the 100 tasks in a minute. So that's what actually increases throughput. Economy of the scale. So with that actually I can able to scale up my project and increase the reliability, graceful degradation or fault tolerance. So reliability in the sense of that, suppose somewhere actually I will keep the multiple copies, and if one way actually something is also failure, I have a backup copy so that I can able to retrieve back the information. That is increased reliability, graceful degradation or fault tolerance. So I will put the checkpoints. With that actual checkpoints, I can able to come back. Suppose anywhere a system is failure, from that checkpoint to checkpoint, I will store it and bring it back from the back end to system. Actually, this is nothing but increased reliability. So under this, you may come across asymmetric multiprocessing and symmetric multiprocessing. Asymmetric multiprocessing is in the sense of that each processor is assigned a specific task. Specific task. So in symmetric multiprocessing, that we will discuss in the later, each processor performs all tasks. So here, asymmetric multiprocessing, one processor is assigned specific task. Symmetric performs all the tasks. Now, come to the operating system operations. A bootstrap program. We already discussed in the before slide. So even your operating system has to be start. We require a tiny program which is a kernel, and inside that kernel, this bootstrap program will be resided. This program contains a code to initialize the system, to start the system, load the kernel. Right? Once actually, see, you have a computer, now you have a operating system. So this bootstrap program will be resided. It's resided in row, read-only memory. You never going to be lost. And this program, because sometimes actually if you observe that your system is crashed, then the people may ask you, can you able bootable disk? Do you have any bootable disk to start your system? So now actually those things are available inside the cloud. In olden days, actually we will keep that bootable CD and we will keep it next. Suppose any time actually if the system is going to stuck up or system is not even start, then actually we will use that bootable CD to make the system is going to start. So it is a very tiny program. What it is going to do, it is also very important bit. Which program is start your operating system. A code to initialize the system and load the kernel. That is bootstrap program. So here, once the bootstrap program is completed, then the kernel will be loaded. So after once the kernel is start running, kernel is also a system application. It's not user application. It's a system program. Once the kernel is start, then it will start all the system daemons. So the services, the daemons is nothing but the services. All the different services, right? See, suppose if you take any organization, you will provide, I am going to perform all these services, right? So like the same, the operating system is a collection of the system daemons. Services provide outside of the kernel. The kernel is interrupt driven. either of the hardware or software. Hardware interrupt by one of the who is actually that interrupt will be enabling. The device only will be enabled. The devices are nothing but CPU, IBO devices, memory, and all these are different, right? These hardware interrupt by one of the devices, and software interrupt, exception or trap. So these are interrupt. Sometimes some in the gate examination they will ask trap is a software or hardware interrupt. So then what is the answer? The answer is trap or exception is a software interrupt. So if the device is initiating the interrupt, that is a hardware interrupt. So if what are the software interrupts? Software error, division by zero, and request for operating system service system calls. System call is also a software interrupt. Other process problems include infinite loop, process modifying each other of the operating system. These are all commended to the software interrupts, right? Now we will look at in the next session the types of operating system. So these are the different operating systems. Commended slowly. I can say another words. These are evolution of different operating systems. So the first is simple batch system, multi-programmed batch system, multi-processor system, desktop system, distributed operating system, clustered system, real-time operating system, handheld system. So today I want to conclude the session. So in next session we are going to discuss this different types of the operating system. So what we learned till now is first we learned what is meant by operating system, what are the different goals of the operating system, what are the different perspectives or user point of view, system point of view, how actually the operating system will be act, what operating system will be doing, what are the different components of the operating system, and now CPU operations, computer system operations, computer system organization, under computer system organization you have learned. So different interrupts, how actually the kernel, different single process system, multi-process systems, and all these we have learned in today's session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.